All right, so let's talk through this identity. And I'm going to think it through as I do it. I haven't tried this problem yet. I'm going to show you the process of solving this. So first of all, don't work over the equal sign. So you can do it a couple ways. You can just keep working on one side of the equation and then don't ever work on the other side of the equation. Or there's other ways. I'm going to do it like this. So first thing to do is I'm going to recognize that I want to multiply this equation. A lot of times when you see stuff like this, see how I've got two terms and I'm equaling one term. So when that happens, that means I need to somehow combine these two things together. And in order to do that, I could either get a common denominator right now, which I could try that. Just call this 1 plus sine x. In fact, I'll do that first. I'm going to call this 1 plus, multiply this by 1 plus sine x over 1 plus sine x, so that I have 1 plus sine x plus cosine squared x all over 1 plus sine x. In fact, I am going to start with that. I'm going to do it that way. I like that. Why would I do that, you ask? Well, because now that I see this, I realize, oh, you know what I have? What does this thing equal?
1 minus.
It equals 1 minus sine x. So I'm going to remember, always write equals sine x on the right, okay? So now I'm going to rewrite that as 1 plus sine x plus, and now I'm writing cosine squared x as 1 minus sine squared x. Pythagorean identity, all over 1 plus sine x. And remember, that should equal sine x. I'm just trusting that this is going to work out in the end. Okay, is this parentheses even necessary at this point? Do I really even need them? No. So what do I have? I have 2. I'm going to rewrite this as negative sine squared x. Put it in order, right? And usually you put the higher squared terms at the front. Plus sine x plus 2 over 1 plus sine x. See what I did there? This is looking like a quadratic equation to me. So let's see if we can factor it. You know what I bet it's going to factor into? I'm not really sure, but I hope it's going to factor into 1 plus sine x, so that those can cancel. So, I'm sorry, sine x plus 1. Sine x plus 1. And negative sine x plus 2.
Bro.
Does that work? 2 sine x minus 1 sine, that works. See how that factored? Why did I assume it was going to factor into that? Because I was sure hoping that this thing would cancel with one of those, and so I just assumed it was going to work out, and if it didn't, I would just go in a different direction. Although that doesn't equal sine x, so I'm a little bit concerned about that. You sure this equals sine x, not 2 minus sine x?
I did a different.
Oh, this is a totally different problem. This says negative. I'm so sorry. This said negative at the very beginning, which makes a lot more sense. So if that's negative up there, what is that going to change? This is a negative cosine, which means this is a negative, which means the ones cancel. There we go. There we go. All right, yeah. Start with an identity that's actually true, and it'll work out. So that, see what it's, same things, right? But now when I distribute that negative in, what happens? The ones cancel, and I just get sine squared x plus sine x over 1 plus sine x. And do you see what's going to happen now? When I square, or when I factor out a sine x out of the top, what do I get? Sine x plus 1 all over 1 plus sine x. And now what happens? Do you see how those cancel out? And I just get sine x equals sine x. So that worked. Now, is that the only way you could do that problem? No.
Did it the right way.
That's one way you could do the problem. Let's see if there was another way we could have done a problem. Let's just erase all of it and let's see if there's another way we could have done it. Because my point is that a lot of times, most of the time, there's more than one way you can get to the problem. And so let's try it a different way. So another way you could have done it is by saying, well, a lot of times when I have things like this, I need to multiply it by 1 minus sine x on the top and bottom, like by the conjugate. So let's rewrite this as 1 minus cosine squared x times 1 minus sine x all over 1 plus sine x times 1 minus sine x just ends up equaling what? 1 minus sine squared x. Got it?
Yeah.
So hey, that would have worked too. Now, what can I do with 1 minus sine squared x? What's that equal? Doesn't that equal cosine squared x? So this is 1 minus cosine squared x times 1 minus sine x all over cosine squared x. Remember, we always write our equal sine x over there because we want to keep the equation like we're not working on the right and left side of the equation. Got it? What happens to the cosines? 1 minus sine x. Be careful with your parentheses. And when I distribute that negative in, what happens? The ones cancel out, and I get sine x equals sine x. So that actually maybe was even a little bit easier, but you could do it either way. Either way would work.